Physics behind tennis. There are several formulas that can explain how physics pertains to the game of tennis. The formula for the conservation of angular momentum explains that the angular momentum of the racket and the ball before the impact is equal to the angular momentum of the racket and the ball after the impact. Another formula that we used was the formula to calculate the center of percussion, or the sweet spot. In this formula, M is the racket's mass, R is the distance from the player's hand to the center of mass, and I denotes the amount of the moment of inertia, which in this case is the racket's swing weight. Gravity plays a vital role in the game of tennis. We use the formula F equals M times G, in which the F denotes the amount of gravitational force, M is the mass of the ball, and G is the constant of Earth, which is 9.8 meters per second squared. We use the impulse momentum theorem to calculate the amount of impulse that is delivered from the tennis racket to the tennis ball upon impact. The impulse is equal to the change in the ball's momentum. In this formula, J denotes the impulse and P is the ball's momentum. A tennis ball will experience drag force throughout the course of a match. According to Knoll, the force acts in the opposite direction of the ball's motion. In this formula, C is the drag coefficient, P is the density of the air, A is the cross-section area of the object, and V is the velocity of the ball. Tennis is a very competitive sport of strategy and skill. This game originated in France during the 12th century and was known as Jeu de Paume, which is translated to the game of palm. This game is still played today. Modernized tennis is a very popular sport played worldwide and became most popular in the 1960s. Tennis is played with either two players competing, which is known as singles, or two pairs of players competing, 4 players total, which is known as doubles. These players use rackets to hit a ball over a rectangular net. In order to score a point, a player must fail in returning the ball to his opponents. Because tennis is a game of strategy, how a racket is handled is essential, and the correct way to handle the racket has to do with physics. Also, the specifics in which a racket is made and the ball are very important as well. According to BBC Sports, a racket size in length should be no longer than 29 inches and the width should be no more than 12.5 inches. The string material also plays a huge role in how the game plays out. Most strings are made of synthetic nylon or titanium, but most professionals prefer gut strings, which are made from the stomach linings of animals. The strings are important because they exert a restoring force on the ball. According to college physics textbook, a restoring force always pushes or pulls an object toward the equilibrium position. As for the tennis ball, according to the International Tennis Federation, a tennis ball's mass should be 56 to 59 grams, and the diameter should be no more than 6.54 to 6.86 centimeters. Newton's laws of motion control the movement of objects. Therefore, they regulate the movements in tennis. Newton's second law states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. Therefore, when a racket strikes a ball, this law is at work. The formula for this law is F equals M times A, in which F is the force, M is the mass, and A denotes the acceleration. Newton's third law of motion states for every action there is an equal and opposite reaction. So, in tennis, the force exerted on a ball by the racket is equal in magnitude and opposite in direction. There are many forces acting on a tennis ball throughout the course of a tennis match. Perhaps the most important of these forces is the force of gravity. The reason being, without gravity, the ball would not bounce at all, and there would be no tennis match to play. The force of gravity causes a constant acceleration on the ball, and according to Knoll, it acts downward on the ball and perpendicular to the court surface. The formula in order to calculate this constant gravitational force is F equals m times g. G being the constant 9.8 meters per second squared. The mass of the ball was given before and is 57 grams. Therefore, the constant force on the ball is 0.56 newtons at any given time throughout the match. Another parameter to consider is impulse. An impulse is delivered to the tennis ball upon impact from a tennis racket. This impulse is equal to the change in the ball's momentum and given by the formula below. Another force to consider is drag force, which a ball will experience throughout a match. Knoll suggests that this force acts in the opposite direction of the ball's motion. The formula states that the drag force is equal to 1/2 c times p times a times b squared, where c is the drag coefficient, p is the density of the air, a is the cross-section area of the object, v is the velocity of the ball. After observing this formula, it's apparent that the drag force has a direct relationship with the velocity, and therefore, when the drag force increases, so will the ball's speed. Perhaps the most essential place on a racket is the sweet spot, also known as the center of percussion. We can calculate the center of percussion using the formula Q equals I divided by M times R, in which Q is the center of percussion, I is the moment of inertia, which is the racket's swing weight, R is the distance from the player's hand to the center of mass, and M is the racket's mass. While it may seem that the reason that this is a very important part of the racket because it would provide the maximum ball speed, that's not the case. The reason is that it provides the cleanest shot and allows a very small amount of force to be transmitted back to a player's hand. On a racket, the frame is there to absorb energy from impact, although it doesn't absorb all of the energy. The net force on the hand is never zero, no matter if the ball is hit directly on the sweet spot. Rotation, translation, and vibration are all motions in the racket handle that distribute force to the hand. The recoil of a racket head exerts torque on a player's hand, causing rotation about the wrist. Torque generated by a racket can greatly affect the outcome of a match. Another very important place on a racket to be aware of is the racket's dead spot, which is located near the very top of the racket. The dead spot is the direct inverse of a sweet spot. On this location, a ball will not bounce at all. So during a match, it can be very crucial not to hit a ball here because it could end the point very quickly. At this location, the racket strings absorb all of the energy of the ball and give none of it back, which results in no bounce from the ball. The reason behind this is the effective mass of the racket, which is the ratio of force at that point to the acceleration at the same spot. Therefore, if F equals m times a, consequently, m equals F times a, where F is the force, m is the mass, and a is the acceleration. This spot is a great spot when overhead serving. However, again, when returning a ball, it needs to be avoided because it could end a point. Another aspect to be aware of is the rotation of the tennis ball itself. A player can create different amounts of spin on a ball to enhance his chances of winning, but it could also result in losing very quickly. The spin of a ball is determined by the speed, angle, racket tilt, and string type of the player. The spin also can affect the trajectory and bounce of the ball, which again affects the entire outcome of the match. The most favorable ball spin amongst players is called topspin. With topspin, a ball will rotate forward over itself. In the picture to the left, it is obvious that in order to achieve topspin, a player must swing his racket in a manner that the head of the racket rotates over top of the ball, often swinging the racket from a low position to a high position. Another technique to achieve topspin is to hit a returned ball once it bounces and is on its way back down to the ground due to gravity, instead of hitting a ball directly after it bounces up on its way to reach its maximum height. When this type of spin is placed on a ball, it rotates forward starting from a high position and drops sharply after clearing the net, which makes it very hard for your opponent to return. Hitting the ball harder results in more topspin, which then results in a much higher velocity of the ball. The result of this type of shot reduces the amount of kinetic friction between the ball and the court when it comes into contact with it. And again, this also increases the angular velocity. Another popular ball spin is known as backspin, but also called a slice or a drop shot. The reason it got this name, drop shot, is because if executed correctly, a ball will clear the net and almost immediately stop, or just drop over the net. This is a very effective shot because it is incredibly hard for a player to reach the net from the baseline fast enough to catch a ball on the first bounce. Now it is shown in the picture to the left that for a player to achieve this shot, they must tilt the racket's head back and strike the ball from underneath. What sets this apart from topspin is that the ball will rotate backwards and the tangential velocity will be in the opposite direction of the trajectory. When this ball finally drops and comes into contact with the court, the backspin effect will cause a reversal in the direction of the spin when it bounces. Enough backspin can actually result in a tennis ball bouncing and then traveling back towards the direction in which it was shot from. Now, the disadvantage to this shot is that it travels at a much slower speed than topspin, but it is considerably more precise.